Hello, this is MEI Core Pure. We're in the Sequences and Series section and on the fourth video on using the standard formulae to find combined sums. You can watch the video straight through, but you will probably find it helpful sometimes to pause the video and try things out for yourself before continuing to watch. We can use the standard formulae to work out other sums. Here's an example. We're asked to find the sum from r equals 1 to 50 of r squared plus 3r plus 1. We've got our formulae from last time for the sum from r equals 1 to n of r and the sum from r equals 1 to n of r squared. So we can split this sum up. We can collect all the r squared terms together, and that will give us the sum from r equals 1 to 50 of r squared. And we can collect the 3r terms together, which gives us the sum from r equals 1 to 50 of 3r. And we can collect all the 1's together. Don't forget that we saw last time that we can take out that factor of 3 outside the sum. Now, using my formulae with n equals 50, the sum for r squared is going to be 50 times 51 times 101 all over 6. And then I've got 3 times the sum for r, so that's 3 times 50 times 51 all over 2 plus 50. That's 42,925 plus 3,825 plus 50, which comes out to be 46,800. Alternatively, we might want a general expression for that combined sum. So I split it up as I did before. The sum from r equals 1 to n of r squared plus 3 times the sum from r equals 1 to n of r plus the sum from r equals 1 to n of 1. Then I simply write in the formulae. The formula for r squared, n times n plus 1 times 2n plus 1 all over 6 plus 3 times n plus 1 all over 2 plus n. I need to tidy this up, and the worst possible thing to do at this point is to multiply out all of those brackets. It will make an algebraic nightmare. Instead, I'm going to take out some common factors. The first common factor is easy to spot, and that's n. I'm also going to take out a factor of 1/6. That's straightforward for the first term, but to make that clear on the second term, I need to make that half into a sixth, and then that 3 will become a 9. So 9/6 is the same as 3 over 2, so I can take out that 6. And for the n, I'm going to make that 6n over 6, so that I can take out the factor of a sixth. That then gives me n plus 1 times 2n plus 1 plus 9n plus 1 plus 6. Now I multiply out the brackets. I've got 2n squared plus 3n plus 1 plus 9n plus 9 plus 6. That's n over 6 times 2n squared plus 12n plus 16. I can take out a factor of 2 and cancel it with the 6 to give n over 3 n squared plus 6n plus 8, and then I can factorise that quadratic expression to give me n over 3, n plus 2, n plus 4. Sometimes the sums don't start at r equals 1, and it's very easy to make mistakes with the limits here. If I'm summing from r equals 10 to 40, that's the same as taking the sum from r equals 1 to 40 and subtracting the sum from r equals 1 to 9, because I need 10 in the sum. 10 is included, so I want to get rid of the numbers up to 9. So that's the sum from r equals 1 to 40 of r squared minus the sum from r equals 1 to 40 of 1. Take away the sum from r equals 1 to 9 of r squared minus the sum from r equals 1 to 9 of 1. Taking care again with the brackets because I've got too many negative signs. Okay, that's 40 times 41 times 81 over 6. Take away 40. Take away 9 times 10 times 19 over 6. Take away 9. That's 22,140. Take away 40. Take away 285. Add 9, which is 21,824. There are more notes on integral on using the standard formulae to find combined sums. That's the end of this short video. The next video in this series is on the method of differences.